Have you ever wondered why Neptune, the eighth planet from the Sun, is so mysteriously blue? Ah, Neptune, a world shrouded in an enchanting shade of azure, a color so deep and captivating it rivals the most beautiful sapphires. But what gives Neptune its brilliant blue hue? Well, my curious friends, the secret lies in the composition of Neptune's thick atmosphere. It's mostly made up of hydrogen, helium, and a sprinkle of methane. Yes, you heard that right, methane. This simple molecule, composed of one carbon atom and 4 hydrogen atoms, is the key to Neptune's blue mystery. Now, you might be wondering, why does methane, a colorless gas, turn Neptune blue? It's a fair question, and the answer lies in the science of light. You see, sunlight is made up of a spectrum of colors. When sunlight reaches Neptune, the methane in its atmosphere absorbs the red light and reflects the blue. This reflection is what we see when we look at Neptune through a telescope, giving us the impression of a blue planet. But Neptune's blue isn't just any blue. It's a deeper, richer shade than the blue of our home planet, Earth. This tells us that there's something more in Neptune's atmosphere, something that enhances its blue. Scientists speculate that this something could be an unknown component, a mystery still waiting to be unraveled. So, Neptune's mesmerizing blue is a tale of methane, light, and a touch of cosmic mystery. It's a color that has fascinated astronomers and space enthusiasts for centuries, and yet, it's just one facet of this distant planet's allure. Now that we've painted a picture of Neptune's enigmatic color, let's journey back in time to its discovery. Because you see, the story of Neptune is not just about a blue planet. It's a story of human curiosity, scientific rivalry, and a quest to understand the cosmos. It's a tale that takes us from the comfort of our home planet to the farthest reaches of our solar system. And it all begins with a mystery wrapped in blue. Neptune was not discovered with a telescope, but with the power of prediction and mathematics. How so? You may wonder. Well, let's delve into the fascinating story of the discovery of the eighth and farthest planet from the Sun in our solar system. Back in the mid-19th century, two brilliant minds, Urbain Le Verrier and John Couch Adams, were independently studying the planet Uranus. They were both intrigued by irregularities in the planet's orbit that couldn't be explained by the gravitational pull of the known planets. This led them to hypothesize that these oddities might be the result of the gravity of an as-yet undiscovered planet. Le Verrier and Adams didn't have high-tech telescopes or space probes. No, what they had was the power of mathematical prediction. Le Verrier, working from the Paris Observatory, and Adams from Cambridge, England, used Newton's laws of motion and universal gravitation to predict where this unseen planet might be located. In a fascinating twist of fate, Le Verrier's predictions made their way to the Berlin Observatory, where astronomer Johann Gottfried Galle received them. Armed with Le Verrier's calculations, Galle looked to the stars and, lo and behold, he found Neptune, barely a degree from where Le Verrier had predicted it would be. This was in September of 1846, and it marked the first time a planet had been discovered by mathematical prediction rather than by direct observation. The discovery of Neptune was a triumph for science. It demonstrated the power of mathematics to predict natural phenomena and reinforced the universal applicability of Newton's laws of motion and gravity. But it was also a testament to the power of human intellect and curiosity. That, my friends, was the birth of our understanding of Neptune, a planet discovered not by sight, but through the power of intellect and prediction. So remember, whether you're gazing up at the night sky or wrestling with a challenging problem, sometimes the unseen can be discovered and mysteries can be solved through the power of prediction and intellect. Did you know that for 20 years of its 165-year orbit, Neptune is actually farther from the Sun than dwarf planet Pluto? Yes, you heard it right. You see, Neptune follows an elliptical or oval-shaped orbit around the Sun. This path is slightly tilted compared to the plane in which most other planets circle our star. Now let's consider Pluto for a moment. This small celestial body also follows an elliptical orbit around the Sun. But here's the catch. Pluto's orbit is much more eccentric or elongated compared to Neptune's. This results in an interesting cosmic dance where, for about 20 years in every 248-year cycle, Pluto moves closer to the Sun than Neptune. This orbital swap doesn't happen overnight. It's a slow, gradual transition that takes place over years. The last time this swap occurred was between 1979 and 1999. During these years, if you were to take a trip from the Sun to the edge of the solar system, you would have reached Neptune before you reached Pluto. This orbital swap has some fascinating implications. For instance, it challenges the traditional idea of a planet's order based on distance from the Sun. But don't worry, even when Neptune and Pluto swap places, they never come dangerously close to each other. Thanks to an orbital resonance, for every 3 orbits Neptune completes around the Sun, Pluto completes 2. This synchrony ensures they maintain a safe distance from each other. But here's another mind-boggling fact. Even though Neptune is, on average, the farthest planet from the Sun, it is not always the coldest. Uranus, its celestial neighbor, often records lower temperatures. Fascinating, isn't it? The dance of these distant celestial bodies reminds us of the dynamic nature of our solar system. It's a testament to the constant, ever-changing motion of celestial bodies in the vast cosmic ballet. So, for a brief period in our lifetime, Neptune might not be the farthest planet from the Sun. Interesting, isn't it? Imagine winds so strong that they could break the sound barrier. Welcome to Neptune. As we continue our journey through the solar system, let's take a moment to discuss Neptune's extreme weather conditions. This is a planet that practically screams extreme, and its weather is no exception. The winds on Neptune are nothing short of extraordinary. Unlike the gentle breezes we're used to here on Earth, Neptune's winds are more like unstoppable freight trains, moving at incredible speeds. Picture this: winds that reach up to 1,500 miles per hour. That's faster than the speed of sound. It's as if Neptune is constantly in the grip of a colossal, never-ending storm. To put it in perspective, the most powerful winds ever recorded here on Earth, in the midst of a tornado, were around 300 miles per hour. Neptune's winds are 5 times that speed. It's a world where the phrase, "hold on to your hat," takes on a whole new meaning. What's fascinating is that these super-fast winds exist in a planet that receives very little energy from the Sun due to its distance. Scientists believe these winds are generated by heat from within Neptune itself. The planet's internal heat source, combined with its rapid rotation, results in a kind of supercharged weather system, unlike anything we see on other planets. These winds don't just affect the planet's atmosphere, they also create dramatic features on Neptune's surface. The swirling dark spots observed on the planet are storms, similar to Jupiter's Great Red Spot, but with much faster winds. It's not just the speed of Neptune's winds that's impressive, it's also their persistence. These winds have been howling around the planet for decades, if not centuries. They're not just a temporary phenomenon, they're a fundamental part of Neptune's character. With winds that could make even the fiercest earthly hurricane seem like a gentle breeze, Neptune truly is a world of extremes. So the next time you're caught in a gust of wind, spare a thought for the relentless, super-fast winds of Neptune. Neptune, the windswept blue giant, is not alone. It's accompanied by 14 known moons. Yes, 14. Each with its own unique dance in the cosmic ballet around the 8th planet from the Sun. Let's shine a spotlight on the prima ballerina of this celestial troupe, Triton. Triton is Neptune's largest moon, and its behavior is quite peculiar. Unlike most moons in our solar system, Triton orbits Neptune in a direction opposite to the planet's rotation. This is what astronomers call a retrograde orbit. Now, isn't that a rebellious move? This strange dance has led scientists to believe that Triton was not always Neptune's moon. The popular theory is that Triton was once a free-spirited dwarf planet, wandering the Kuiper Belt, the region of the solar system beyond Neptune's orbit. But then, in a fateful encounter, Triton got too close to Neptune and was snared by its powerful gravitational field. Imagine being a dwarf planet, minding your own business, only to be captured and forced into a dance that goes against the grain of your nature. That's Triton's story, a testament to the immense gravitational force of Neptune. But don't think of Neptune as a bully. Instead, consider it as a master choreographer, directing the movements of its moons in a grand cosmic ballet. Each moon follows its own path, dictated by Neptune's gravity, creating a spectacle of celestial choreography that's nothing short of awe-inspiring. And Triton is not the only interesting character in this dance. Other moons of Neptune, like Proteus, Larissa, and Nereid, Each contribute to the complex interplay of gravitational forces that shape the Neptunian system. So when we look at Neptune, we see more than just a distant blue giant. We see a gravitational maestro conducting a symphony of celestial bodies in a dance that's as beautiful as it is complex. From a rogue moon to a celestial dance of gravity, Neptune's moons add another layer to its intriguing persona. Despite its fascinating characteristics, Neptune remains largely unexplored. But why? Well, the answer lies in Neptune's location and conditions. Nestled deep in the cold, dark corners of our solar system, Neptune is over 2 billion miles away from Earth. That's a distance so vast that light from the sun, traveling at a blistering 186,000 miles per second, takes over 4 hours to reach it. This immense distance makes it incredibly challenging to send spacecraft to Neptune. Even using the most advanced propulsion technologies available today, a journey to Neptune would take nearly a decade. And that's if everything goes perfectly. But the challenges don't stop there. Even if a spacecraft manages to reach Neptune, it would be confronted with some of the harshest conditions in the solar system. With temperatures plunging to -350 degrees Fahrenheit and winds whipping at speeds of more than 1,000 miles per hour, Neptune is not a welcoming place. Despite these challenges, one brave emissary from Earth has managed to visit Neptune, Voyager 2. Launched in August of 1977, Voyager 2 conducted a flyby of Neptune in August of 1989, providing our first close-up views of this icy giant. Voyager 2's images revealed a world of surprising complexity, with massive storms, dark spots similar to Jupiter's Great Red Spot, and a system of thin, faint rings. But as incredible as these discoveries were, they only scratched the surface of what Neptune may hold. As we continue to develop new technologies and methodologies for space exploration, the prospects for future missions to Neptune become more feasible. There's so much we don't know about this distant, icy world. It's like an alluring blue siren singing its song across the vast ocean of space, beckoning us to come closer and uncover its secrets. As we continue to push the boundaries of space exploration, who knows what secrets Neptune may yet reveal? Until then, it remains a beautiful blue mystery. So, what have we learned about the intriguing planet that is Neptune? We've delved into its discovery, a celestial mystery solved in the 19th century, revealing Neptune as the farthest planet from the Sun in our solar system. A distant world of blue, racing around the Sun at incredible speeds, the fastest in our solar system, despite its distance. We've delved into its elliptical orbit, a dance of gravity that takes an astounding 165 Earth years to complete. And we've marveled at Neptune's extreme weather conditions, with winds whipping up to 1,500 miles per hour. We've explored its moons, particularly Triton, an icy world that spins in the opposite direction to Neptune's rotation. And we've recognized the challenge and excitement of exploring Neptune, a world yet to be fully discovered, a world still cloaked in mystery. As we unravel the mysteries of the universe, Neptune serves as a reminder of the beauty and intrigue that lies beyond our own world. A mystery indeed, wrapped in blue.